U.S. Highway 220, that's the curved white line, had been rerouted to keep it away from the river, that's the black area. But as a result of flooding caused by severe storms, the stream gradually moved back toward the new road. Another storm could possibly wash it away. Engineers at Pennsylvania State University's hydrology lab went into the field to look the situation over. They found that the soil was rocky and lacked clays that would bind it together. They concluded further erosion would probably take place. Because the flow patterns of the stream made it difficult to apply the usual mathematical formulas, the engineers decided they needed a working model of the stream. They duplicated the lay of the land around the stream and within it by using plywood cutouts for a foundation. The plywood forms were filled in with sand and then covered with a layer of concrete. To make the model behave like the real river, the right dimensions had to be used. A different scale was used for length than was used for height. Wooden pegs were set into the stream bed to create the kind of surface turbulence of the real stream. To test the design, flood conditions that actually happened were duplicated. The high water level matched the predicted volume and velocity of the water, so the model behaved like the actual stream. Now it could be used to test conditions that would be impossible to change in the field. Would a sandbar on the left shore return, even though the highway department had dredged out the sand? By using fine sand in the water, the model showed it would indeed build up again. By using sand and gravel on the right bank, the model showed engineers that the control measures built on the real creek would be washed away in the next flood. They experimented with dikes that would steer the main flow of the water away from the right bank and the highway. Confetti in the water helped make the flow patterns visible. It appeared that the dikes would also cause less sand to be deposited on the left bank. Dike models closer to the actual design were put in place and tested. Thus, the engineers at Pennsylvania State University's hydrology lab were able to answer many questions about the real stream because they had built and tested a scientifically accurate model.